Hello, my name is Rich DeYoung. I'm a senior technical instructor for Ansys Government Initiatives. Today's short video is an introduction to STK 12.8, the new chain object, and how to use optimal strands. So engineers and operators require a quick and simple way to simulate multi-hop relays of information between satellites and ground sites. The scenario used in this video shows a combination of satellites and ground sites working together. A satellite will take as many pictures of the Roman Coliseum as possible and return them to White Sands or Guam during a 3-week analysis period. Using STK 12.8, you will determine when to take images of the Coliseum in daylight over a 3-week analysis period. The cameras are attached to 2 operational landsat satellites. They will take the pictures. The images are uplinked to an operational TDRS satellite and then downlinked to either White Sands or Guam in near real time. TDRS satellites in the same constellation can pass the image to each other if required. With STK 12.8's new chain object, processing delays and link distance will be taken into account in the analysis. So in STK 12.8, the chain optimal strand properties allow you to determine the best strands for a computed chain based on a specified metric. When computed, all possible strands from the start object to the end object through the specified connections are determined, and timed valid access intervals are stored for each strand. The resultant intervals for each strand simply records when the start object can see the end object through the objects in that strand. In this video, distance and processing delay are analyzed. Distance is just the sum distance between the object pairs in a strand, and light time delay is not taken into account. Processing delay, that's the sum time values of the processing delays specified by each object in the strand, plus the light time delay between the object pairs in the strand. The light time delay between object pairs is computed simply based on the object's positions divided by the speed of light. The first object's processing delay is not included. So to give you an overview of what we got going on here, you can see we have some landsat satellites, we have some TDRS satellites, we have the Roman Coliseum, which is our target object. And then we have 2 ground sites. We have White Sands, and then over here in the darker side of the Earth, we have Guam. So the whole purpose of this is for one of the Landsat satellites, the satellite has to pass over Roman Coliseum. If the Roman Coliseum falls within this field of view of the sensor is going to give that information to its parent. The parent, in turn, will send that information or image to a TDRS satellite that it can see. It has to be able to see the TDRS satellite. The TDRS satellite, in turn, is going to have to be able to see either White Sands or Guam. And that's where we use the chain. So the first thing we have to do with the new chain object in STK is to define our start and end objects. So I'm simply going to go ahead and go into the properties of my chain. I call the chain Coliseum to ground, just to give it a name. And in the properties, here's the new thing right away. You have to pick where the information is going to begin and where the information is going to end up. So I'm going to go up here to the start object. I'm going to click on the ellipsis button and open up the select object dialog, and everything's going to start at the Coliseum. So I'm simply going to pick the Coliseum as my object, click OK, and then my end object is going to be one of my 2 TDRS ground sites. It's either going to be White Sands or Guam. Because I've got them grouped in a constellation object, which you can see over here in the object browser, I have my TDRS ground sites both inside of this constellation object. I'm simply going to pick the constellation. So I'll click End Object and pick the TDRS ground constellation and click OK. So this is the new thing in STK, is the connections. So in the past way of using a chain object was to pass it from where it was going to start to the next object, to the next object, to the next object. Now you just build all the possible connections down here in the connections list. So I'll just show you, I'll just do one, and then I'll finish it up and we'll come back to this. So basically I'm going to click Add. My first connection is going to be from the Coliseum to one of my 2 sensor objects. So this is where you do it. You pick a from object and a to object. So I'm going to go ahead and click the ellipsis for the from object. The from object is going to be Coliseum. And my to object is going to be one of my 2 cameras. So I'll go ahead and select the constellation with the 2 sensors in it and click OK. That's the first step. Then if you're going to continue, the cameras are going to pass it to their parent. So we have this little button over here on the right called Extend. I just click Extend. It already has the camera field of view as my from object, I just need to go to the to object and pick the landsat sats constellation. So if we look at our connections, you can see all the possible connections in this connections list. And it doesn't matter how you put them in here. It's just which objects can talk to which objects. So you can see my camera fields of view can talk to the Landsat satellites. My Landsat satellites can talk to the TDRS satellites. The TDRS satellites can talk to the TDRS ground site. TDRS satellites can talk to TDRS satellites. So this is a way to pass images between TDRS satellites in the same constellation. And then also the other connection is Coliseum to the fields of view. So I have every possible connection: Coliseum camera field of view to the Landsat sats, Landsat sats to the TDRS sats, TDRS sats to TDRS ground, or if I desire, I can also pass information between the actual TDRS satellites themselves. Just real quick, I'm just going to do a complete chain access report. It just uses this report to analyze whether or not you have accesses during your scenario analysis period. Complete chain access reports the time intervals for which the chain is completed. So I'm just going to go up to the chain object, right click on it in the object browser, and open up the report and graph manager. When I get into the report and graph manager, I'm going to locate the complete chain access report, and I'm going to generate that report. So I can see in the report I have 3 accesses at this time. Basically, it's just when one of those sensor objects passes over to Coliseum and then who it can pass it to inside that chain. If I right click on this first start time and jump to it, I can actually visualize this in the 3D graphic window. And you can see that it's busy. But if I go to the Landsat satellite, and it looks like it's Landsat 9, I can see that it's passing over the Coliseum, and then in turn, that satellite can see multiple TDRS satellites out in the distance, and those TDRS satellites can also see other TDRS satellites, and then in the end, you can see that some of those satellites are going to downlink to Guam, if that's what I choose to do, or some of those TDRS satellites can downlink to White Sands. So it really comes down to what do you want to pick, which link do you want to choose. I can also see that in the 2D graphic window if I zoom all the way out in the 2D window. See all those possibilities. So I've returned back to the report and graph manager. There's an important chain object data provider that can provide valuable information to your analysis. It reports the settings used by the chain object when computing available strands. So what I'm going to go do is I'm going to run a report, and it's called valid paths. So if I generate this report, you can see that it's showing me 2 valid paths. One of the paths goes from the Coliseum to the cameras, to the parent land site, to the land site to a TDRS satellite, and the TDRS satellite to a TDRS ground site. But the second possible path is the same thing. It's going from Coliseum to the cameras, to the parent satellite, Landsat satellite, to the constellation of TDRS sats, but the constellation of TDRS sats can also talk to each other. So I can throw in other TDRS satellites in here, and then finally, once again, to the ground site. So the valid path report just shows me the different ways I can send this information, starting at the Coliseum and ending at the TDRS ground site. The strand names data provider and the associated strand names element lists the names of the object and all valid strands for a computed chain. The number of strands element lists the number of strands with valid access intervals. This report's very busy, but again, it's going to show us all the available strands. So I'm going to go over here in the report and graph manager, and I'm going to select computed strands as my report, and I'm going to generate that report. So you can see up here a number of strands. It says 116 strands, and then it shows me all the individual strands that can possibly be used to send this information to one of my 2 TDRS ground sites. So we know we have 116 possible strands, but there's another thing you can do now in the new chain object in STK. So we know we have 116 possible strands. You look on the basic definition page, all of our possible connections default to what's called a maximum number of uses and a value of 1. All this means is it specifies the maximum number of times a connection may be used in a strand. When you generated the computed strands report, it reported how many strands there were based on all of our possible connections being used just once. But maybe you desire 2 possible strands per node in the TDRS satellite constellation. So the first thing I got to do is I got to go up here and locate that constellation, TDRSATs to TDRSATs. And I'm going to come down here to maximum number of uses, and I'm going to change that value to 2. I'm going to apply this and bring that report back up to the front. After I get this gets done here, I'll bring the report back up, and I'm going to refresh the report. And you can see a huge difference. We jumped from 116 possible connections up to 864 now. And that's because we said that each node in that TDRS constellation of satellites could be used twice. That's just another feature that's new in the chain object in STK 12.8. The chain object optimal strand properties allows you to determine the best strands for a computed chain based on a specified metric. Currently, we have approximately 864 strands to choose from. You can narrow this down to choose the time and strand that meets your operational needs. Maybe we want the overall shortest strand. So if I go into the properties, into the basic optimal strand page that I'm sitting on right now, I'm going to come over here and turn on compute. And you can see that it defaults to distance. It also defaults to strand comparison minimum. So basically what I'm telling it right now is to compute distance based on the minimum distance. And it's going to sample every 10 seconds. I'm going to go ahead and apply that. And let's see what happens when I bring the 2D graphic window up to the front. It's going to show you which strand is the best strand based on the distance and minimum between Rome, and in this case, it's going to be white sands. Conversely, we can use a maximum distance strand. Maybe I need to know which strand has the longest distance ascended. So I simply come down to strand comparison and select maximum. Click OK, set my properties. And when I get back out to my 2D window, now it's showing me the longest distance in my strand. And again, it's going to white sands. Maybe I want to find the optimal strand of time. There are 2 reports you can use to determine your optimal strand. One's called optimal strands by time, and the other one is optimal strand at time. These aren't the only reports you can use, but for the purposes of this analysis, we'll just look at those. So I'm going to bring the report and graph manager back to the front. And I'm going to select the optimal strand at time report, and I'm going to generate that report. So in this particular report, it reports the best optimal strand by name and metric value for the sample times when optimal strands exist based on computed chain access. Now, right now, we're doing a really long one, so I'm not picking the middle one. We left it at max, but you get the idea. This is new, this is really cool. I can find out based on that metrics which one is my optimal strand and when it's taking place. Next report is optimal strands by time. I'll go ahead and generate that report. And what this is, it's going to report the optimal strands by name and metric value for the sample times when the optimal strands exist based on computed chain accesses. And this one is just breaking it down that it can see something. It's telling me which strand is the best one based on the maximum distance. Processing delay is an important metric to be taken into account. It is a noticeable latency due to the speed of light when sending data to and from satellites and the distance between the satellites. Speed of light is constant, but other delays could be caused by hardware and software and every device that the signal must pass through. The default processing delay for your objects in this particular scenario default is 0 seconds. We can change the processing delay for one of our objects to see how this works in STK 12.8. Landsat 9 passes over the Coliseum in this particular tutorial. So what I'm going to do is I'm going to go to the basic processing delay page, basic processing delay, and this is where I can add a processing delay for this particular satellite. And I'm just going to go ahead and put in a nominal value just so you can see how it works. So I'll just say 5 seconds. Go ahead and click OK and accept that change. Every time I make a change, it's going to recompute, so it always takes a little bit. I'm going to go back to the properties of Coliseum to ground and go back to the basic optimal strand page. And this time we'll use processing delay. We're going to just keep the strand comparison to max. We're not changing it like give us a shorter strand or anything. We're just going to leave it at max. I'm going to go ahead and click OK. Then I'm going to go ahead and bring that optimal strand by time report back up to the front. You're going to see a bit of a difference now in the report. Instead of distances over here on the right, now it's showing me processing delay values, but now you can see that the processing delay is being added to my analysis, so it's being taken into account in this particular report. So in the end, the overall purpose of this scenario was to determine when you can take pictures of the Coliseum in daylight over a 3-week analysis period and send them to a selected teacher's ground site in near real time to include processing delay and link distance. 2 operational Landsat satellites and attached sensor objects took pictures and relayed them to multiple operational teacher satellites, which then passed them to 2 teacher's ground sites. Image transfer between the teacher satellites was possible, and using the new chain object in STK 12.8, link distance and processing delays were added to the analysis to determine optimal routing. I hope you enjoyed this quick introduction to the chain object in STK 12.8. Have a great day.